Okay, this is the question from the previous GATE paper in the year of GATE 2008. Okay, here the question is given as by a common data, that is nothing but a speech signal band limited to 4 kHz and peak voltage varying between plus 5 volts and minus 5 volts is sampled at the Nyquist rate. Each sample is quantized and represented by 8 bits. If the bits 0 and 1 are transmitted using bipolar pulses, the minimum bandwidth required for distortion free is. Okay, here the given data is that is nothing but FM equal to 4 kilohertz and the peak to peak voltage V peak to peak, that is plus 5 volts to minus 5 volts, that is nothing but the 10 volts, and the number of bits is given as 8. Now we'll see the solution for the first two problem. If the bits 0 and 1 are transmitted using bipolar pulses, the required minimum bandwidth for the distortion free transmission. Okay, for distortion free transmission of bipolar pulses, for distortion free transmission of bipolar pulses, the bandwidth should be 4 times. Okay, the bandwidth should be 4 times of the normal bandwidth. Okay, now the overall bandwidth equal, generally for the PCM the bandwidth equal to Fs minimum. Okay, that Fs minimum is now multiplied with 4 times corresponding to bipolar pulses. Now here the Fs minimum is nothing but 2 into Fm and into 4. Okay, we know that FM value is given as 4 kilohertz, that is nothing but 2 into 4k into 4. Okay, that equal to 32 kilohertz. The minimum required bandwidth for bipolar pulses for distortion free transmission is 32 kilohertz. Now the answer is B. Next, the remaining two questions for the same data is, the first question is, assuming the signal to be uniformly distributed between its peak values, the signal to noise ratio at the quantizer output is. Now, okay, we know that the solution for the 72 question number is, okay, here the simply we have to find out the signal to noise ratio SNR, that equal to 6n plus 1.8 in terms of dB. Okay, where n is the number of bits, that is given as the 8 plus 1.8, 6 8. Now this is the third question for the above common data. Here the question is, the number of quantization levels required to reduce the quantization noise by a factor of 4 would be. Now we'll see the solution for this one. Okay, here we have to denote the quantization noise is nothing but NQ. We know that the formula for the quantization noise equal to delta square by 12, where delta is nothing but the step size. The formula for the step size equal to, that is V peak to peak by 2 to the power of n, where n is the number of bits. Okay, now here to reduce the quantization noise factor by 4, now the new quantization noise NQ dash is considered as the original quantization noise is reduced by 4, that is nothing but NQ by 4. Now for the NQ dash, the formula, the quantization noise is just step size is considered as the delta 1, that is nothing but delta square by 12. Okay, according to the basic formula, that is NQ. In terms of delta, the formula for the quantization noise is this one. Similarly, we will write the same formula, that is in terms of delta square by 12 into this 4. Okay, both are equal. Now from this one, this 12 cancel, from this one, the delta 1 equal to simply delta by 2. Okay, where delta 1 is the step size for the second quantization noise, where delta is the step size for the original quantization noise, that is equal to delta 1 equal to delta by 2. Okay, for the delta 1, the formula equal step size, that is v peak to peak by 2 to the power of n. For this general delta, that is also v peak to peak by, already 2 is there, that 2 into 2 to the power of n. Okay, this v peak to peak, v peak to peak is cancelled, both are common. Okay, from this one, this 1 by 2 to the power of n equal to 1 by 2 into 2 to the power of n. This n is nothing but given as the 8 for the normal step size. Now this is nothing but 2n equal to 2 into 2 to the power of 8, that equal to the 2 to the power of 9. 2n equal to 2 to the power of 9. Then the quantization levels are 2 to the power of 9 is required for the 512. 512 is, that is nothing but the 2 to the power of n. Okay, to reduce the quantization noise by a factor of 4, the number of bits is required as 9 and quantization levels are required as 512. The answer is B.